Assalamualaikum and very good morning to everyone. My name is Muhammad Ridwan bin Abdul Rahim. Today I will present my final year project, which is selective removal and recovery of gold and copper ions from aqueous solution by PKFAD Impregnated Chitosan. For this research, I had been guided by Associate Professor IR Dr. Chen Sihua. This is the outline for my presentation today. Now we go to the introduction. In recent years, the increment of the effluent from various sources containing gold and copper is one of the critical issues facing by developing and non-developing countries. There are a lot of sources contribute to high amount of gold and copper in the aqueous solution, which are pregnant solution, wastewater, and spent process solution. Pregnant solutions are synthesized from the hydrometallurgical leaching process. This process is used to recover the precious metals like gold, copper, zinc, silver from the ore or the e-waste by using different types of leaching reagent. The most common leaching reagents are cyanide leaching, thiourea leaching, halide leaching, and thiosulfate leaching. Electroplating industry also lead to discharge wastewater with containing precious metals. Electroplating process involved in PCB production. The resin process also required high amount of water for the removal of any spot on the metal plate surface after plating process. Therefore, large amount of wastewater containing heavy metal will be generated. Those generated effluent can give significant effect on human and environment. Even though the concentration of gold and copper are low, it is still dangerous since it tends to accumulate and toxic to living organisms. Gold and copper have their own toxin. This toxin can give impact on system, organ and cell. Thus, the recovery of gold and copper from aqueous solution are necessary since it are valuable in global market. There are several conventional methods for gold and copper recovery like solvent extraction, chemical precipitation and ion exchange. Now we go to the problem statement. The most common method that widely used is solvent extraction. Basically, this technique uses combination of extractant and a diluent that also can call as an organic solvent. However, this liquid extraction has some limitation, which is the consumption of the organic solvent is too large. The best solution is by using biosorption process. Biosorption involves a solid phase for the removal of the dissolved species contained in the aqueous solution. For the solid support, the suitable material, which is the abundant green material, become the priority, so that chitosan had been chosen. However, the current chitosan has suffering with some weaknesses such as low thermal stability, mechanical strength, and acid stability. Therefore, some modification need to be done toward the chitosan, whereby the extractant is used, which is the palm kernel fatty acid distillate PKFAD. This is because PKFAD is rich in free fatty acid content and is one of the green extractant. By impregnation method, the PKFAD chitosan bead will be created. Now we go to the research objective. There are two objectives for this research. The first one is to investigate the effects of different parameters on the selective sorption of gold and copper from aqueous solution by PKFAD impregnated chitosan. And the last one is to propose suitable dissolving agent for gold and copper recovery from PKFAD impregnated chitosan by literature review. Now we go to the research gaps. For the research gap, it is crucial to evaluate the performance of the PKFAD impregnated chitosan toward metal ion recovery, since it is the new modification. Other than that, there is no research was reported for adsorption of gold and copper ions by using PKFAD impregnated chitosan. Now we go to the research methodology. For the synthesis of PKFAD chitosan beads, 3 grams of the chitosan powder was weighed using the analytical balance. Then it will be dissolved in 100 ml of 3% by volume of acetic acid. The viscous solution was stirred using the magnetic stirrer for 3 hours at room temperature. 60 ml of the PKFAD was added into the mixture. Then it will be continuously stirred for 3 hours at room temperature. To form the beads, the PKFAD chitosan solution was added dropwise into a methanol ammonia solution 9:1 ratio by using a plastic dropper. The beads were left for 1 hour. After that, the PKFAD chitosan beads were filtered and rinsed with distilled water until the pH of the filtrate became neutral. The beads were dried using oven at 50 degrees C for 24 hours. The beads were ready for adsorption process. For the adsorption process, it had been carried out in 250 ml of conical flask. 50 ml of desired concentration for both Au3 and Cu2 were mixed in the conical flask. The pH of the aqueous solution was adjusted to the desired pH by using 1 molar of hydrochloric acid and sodium hydroxide. The pH of the aqueous solution was measured by using the pH meter. Then desired amount of the PKFAD chitosan beads were added into the solution. The orbital shaker was used to shake the mixture solution together with the biosorbent at 150 rpm for 3 hours. After that, the beads were filtered and using the filtering funnel together with the filter paper. Then the concentration of the filtrate for both Cu2 and Au3 were measured by using ICP-OES. Now let's take a look on the results. For the effect of the pH, the first graph shows that when the pH is increasing, the percentage adsorption and adsorption capacity of Au3 were decreasing. But the trend shows the increasing of the percentage adsorption and adsorption capacity of Cu2. For the second graph, the higher selectivity of Au3 can be achieved at the low pH. At the low pH, the protonation of amine group occurs rapidly, by which the available site for Au3 bind on the PKFAD chitosan bead are relatively high. Comparing with Cu2 ion, the electrostatic repulsion that is induced between the beads and Cu2 ions in acidic condition will reduce the absorption of Cu2 ions. Therefore, the affinity of Au3 ions bind on beads is much higher compared to the Cu2 ions at the low pH. For the effect of initial metal concentration ratio, the percentage adsorption for both Au3 and Cu2 are decreasing with the increasing of initial metal concentration ratio. The saturation of PKFAD chitosan bead occurs rapidly because of more metal ion bind on the limited number of active sites. For the selectivity, it showed that Cu2 are more selective compared to the Au3. This is because the experiment was conducted at higher pH 4.9. The higher pH of aqueous solution will contribute to the low protonation of amine group, which result to low electrostatic repulsion. Therefore, the Cu2 have a great affinity toward the PKFAD chitosan bead at higher pH compared to the Au3. For the adsorbent dosage, the percentage adsorption of Cu2 remain unchanged even though the adsorbent dosage increasing, but the percentage adsorption of Au3 are increased steadily from 53% to 78%. This is because by increasing the adsorbent dosage, it will increasing the number of active sites for the metal ion to form the stable complex. For the second graph, it shows that the increment trend of Au3 selectivity. It can be explained by the number of active sites, which is the amine group, are increasing since it is proportional to the adsorbent dosage. These amine groups that are available for absorb high amount of Au3 compared to the Cu2, which contribute to higher selectivity of Au3 than Cu2. For the desorption and reusability study, there are several elements that have been reviewed. For the recovery of Au3, the most effective is combination of HCl and thiourea. After 5 cycles, adsorption capacity maintained more than 95%. For the recovery of Cu2, HCl and HNO3 and ETA is more effective. After 5 cycles, adsorption capacity maintained more than 90%. Now we go to the novelty. There are several novelties for the PKFAD chitosan beads. Firstly, this biosorbent is low cost since it uses the abundant sources like shrimp and crab shell. It also can be categorized as green biosorbent since PKFAD and chitosan are green extractant and green abundant material. It is also non-toxic and can be used for multi-purpose, which are for heavy metal and dye removals. Thank you.